about the states of matter we have discussed. Okay, the previous class we have discussed about the states of matter. So in today's class, what we are going to discuss is today we shall be going to discuss the change in states of matter. We have discussed the change in state of matter. Are you there in the class, everyone? I'm asking you.
Yes, sir.
So what I'm saying is that we have discussed about the change in states of matter.
Yes, sir.
So how does the state of matter changes? How does the states of matter changes? As you know that when we are just changing the state of matter, changing the state of matter. What are that factors? For example, if you are having some solid particle which are tightly packed, they are tightly packed. Everyone, please turn on your camera. Everyone, please turn on your camera. And then it is gas. Then it is gas. So what we are saying that when we are changing solid to liquids, what happens here is that simply you know that the kinetic energy of the particle increases. Okay, and these are having less kinetic energy, less kinetic energy. Okay, and as comparison to the solid, the particles of liquids have more kinetic energy. And then we keep on giving. That is, uh, it would be simply gas. And when it is going to be converted into gas, that is having the highest kinetic energy. Highest kinetic energy. Are you getting my point? Is I audible to you?
Yes.
Samar? Okay. So when we are changing the states of matter, the temperature remain constant. Why do temperature remain constant? Like for example, you know, please note it down fast. Note it down fast. Chakrika, Naisha, and Tanisha, please turn on your camera button. Tanisha, are you there? Tanisha.
Yes, sir. Sir, can I keep my camera off? I'm not at home.
Oh, So you understood this one, बेटा समझ आया? लिख लिया आपने? Have you noted this one?
Yes, sir.
Okay. So what I'm saying here is that uh, when we are changing the state of matter, then the temperature remain constant. Why do the temperature remain constant? When we or anything when the state of a substance is changed, when the state of a substance is changed, then the temperature remain constant. Can you tell me that why it is so? That why do the temperature remain constant?
Particles absorb the temperature to change the state of their form.
Yes, we'll simply say that when we are changing the states of matter, the temperature remain constant because the heat goes in changing the state of matter in the means. For example, if I'm saying that these are the solid particles, they are tightly packed, and if you want to convert them into liquid states, then these particles should be movable. They must have some fixed kinetic energy. Okay, are you getting a point? समझ आया?
Yes, sir.
So if this is the solid particles and they are being converted into the liquid particles, then क्या होगा बोलो? Then they are having kinetic energy. So when you are supplying heat or it is absorbing the heat from the atmosphere, ऐसा तो नहीं है कि ice को आप heat देते हो तभी melt करता है. Because for melting ice we require 0 degree Celsius temperature. And outside the temperature, this 25 degrees Celsius room temperature is 25, 25, 30, 15, whatever it is, but it is greater than zero. So it will absorb heat from the environment and then get converted into liquid. But we see that even if we are heating the ice, like for example, if I'm having a beaker, okay, and in that beaker, if I'm heating something, if I'm heating something, okay, so when we are heating something, then what would happen? Let's suppose this is the ice cubes present here, ice cubes, and they are melting, and we are supplying heat to it. We are continuously supplying heat. Okay, Abdullah, are you getting me? And if I place a thermometer here, then it will remain at 0 degrees Celsius. The temperature does not rise. Why? They are continuously supplying heat, but it remains 0 degree. Why? Why it remains 0 degree? The reason is very simple. Because the heat goes in overcoming the force of attraction between the particles of solids. Between the particle of ice. Means ice particles are tightly packed. If they are changing their states, then they need to be movable. So that force of attraction which the solid particle, the ice particles are holding together, they need to be overcome. Are you getting the point? समझ आया?
Yes, sir.
So for that, what we need to do is that the particles of solid which is having high force of attraction, the heat you are supplying, it is born in the in overcoming the force of attraction between the particles of solids. Okay, got it? समझ आया?
Yes, sir.
So the question comes in the examination that when we are changing the state of matter, for example, ice to liquid water, why does the temperature remain constant? Why does the temperature remain constant? The reason is very simple that when we are changing the state of matter, got it? The heat goes when ice changes or any solid to liquid water. The heat force temperature does not rise. As the heat force again overcoming the force of attraction between the particles. Sorry. In the form of latent heat. अभी हम लोग डिस्कस करेंगे व्हाट क्या होता है latent heat. In the form of note it down please. Done.
No, sir. Okay, sir, done.
Other students also done.
Yes,
Have you
sir.
noted this one? Everyone. So let me tell you that why do the temperature does not change or remain constant when we are changing the state of matter. Similar for the liquids also. When liquids, you know that liquid, for example, if I'm taking liquid water, so liquid water boils at 100 degrees Celsius. Okay. And you keep on heating the liquids. Let's suppose you are having this one, okay, and you are having water. You start keep boiling it. Okay. And you are supplying heat to it. Okay, and you will notice that if this is 100 degrees Celsius temperature here, this is 100 degrees Celsius. Okay, and it is man. Liquid water, and this is steam. The temperature will remain constant unless and until the whole water get evaporated and converted into vapor. If you continuously supply heat, the temperature will keep on rising 20, 30, 40, 50, 60. 70, 80, 90, and 100. Then will become constant. Constant. It will not rise 101, 102, 103, 105. No, why? Because here the state changing process is taking place. At 100 degrees Celsius, water is converting into vapor. So because of that, the temperature remain constant. So when the state is being changed, then the temperature remain constant. Are you getting a point? समझ आया?
Yes, sir.
Yes.
Temperature remain constant when we are changing the state of matter. So note it down. Temperature, sorry, we have noted this one also already. And when we are changing water into steam, then the heat goes in the form of latent heat of vaporization. We will discuss what is latent heat was. But let me show you that even if a polythene, like a polythene bag, if I'm having a polythene bag, polythene bag, if I'm having a polythene bag, okay, and that polythene bag has a temperature, this is a polythene bag, and this polythene bag, let's suppose it's melt at 150 degrees Celsius temperature. Let's suppose it melted 150 degrees Celsius. So even if you take the water in polythene bag, it will boil, but it will not melt. Why? Because at 100 degrees Celsius, the temperature will become constant, and the heat will goes in converting the water into vapor state. Like for example, you are having a polythene bag. Let me show you with the help of video, and then you will get able to understand what I want to say actually. Just Sorry, beta. Actually, this is because of excess of temperature. The laptop is getting hang. I'm sorry for that, but I'm trying not to use much apps. So this time, we're trying to just. So here it is, but please note it down that my screen is visible to you.
Yes.
So let's you write it down. Like what is latent heat? Then I will show you this experiment also. Okay, so the question is that why do the temperature remain constant and why does let me show you this one. Sorry, matches. Are you there, everyone in the class? Sharika, Abdul, Maisha, where is Tanisha? Tanisha, are you there? Heating of boiling of water and boiling of water in polythene. So when you heat water in polythene, you can notice this one that it is possible that we can heat the water. Okay, we can heat the water and we can boil the water even on the on the in the polythene. Why the temperature is why the polythene is not melting? Why he is keeping this one and continuously heating this one, but the temperature you see that it is not melting. Why does it? Otherwise, if there is no water, it could have melted. Why? Because the heat is going in boiling the water, and water boils at 100 degrees Celsius. Let's suppose water boils at 100 degrees Celsius. So unless and until water reaches 100 degrees Celsius, and let's suppose polythene melt at 120, 150. So it will not let to increase the temperature above 100 because heat is going that at 100-degree temperature, the state change process will take place and water is converted, start converting into vapor. It will keep on continuously converting into vapor and it will not. You can check here that this portion of polythene is getting melted. Why? Because there is no water up to this level. So that's why it got melted because here there is no water. So here the temperature of the polythene may or the temperature may rise above 100 degrees Celsius, which is sufficient to melt the polythene. But here it is not melting because the temperature because the heat is transferred in the water and it is converting the water into vapor state. They will not let it to rise above 100 degrees Celsius. Are you getting the point, Samadhan? Are you getting?
Yes.
Yes.
Okay. So please try to understand this one that whenever there is an energy conversion process, then during that time, the temperature remain constant. It does not change. Got it? And please note it down that what is latent heat first. What is latent heat? So let me write it. What is latent heat first? First, you write it latent heat of fusion. Latent heat is of two types. One is latent heat of fusion and latent heat of vaporization. So, what is latent? The word latent means hidden. Why we are saying it is hidden heat? Hidden heat. Because we know that we are supplying the heat, but it is not related to drive the temperature of the substance we are supplying to it. So, when we are changing the state of matter, the heat is transferred in the form of latent heat. That means hidden because the temperature does not rise unless and until whole substance state is changed. Like for example, if you are converting solid to liquid, the whole water, so whole solid should be converted into liquid. Till then, the temperature will remain constant. Are you getting a point? समझ आया? समझ आया? So what is this? The
Yes.
amount of heat required to change 1 kilograms of solid into liquids at the atmospheric pressure. Note it down, please. Noted what is latent heat? Latent heat of fusion. Latent heat of fusion is the amount of heat that is required to convert 1 kilograms of solid completely into liquid at melting point. At melting points. At its melting point. Are you getting the point? समझ आया? Yes, you
Yes, sir.
Chakrita and Tanisha.
Yes, sir.
Sorry, Naisha. Please turn on the camera. I have turned off the camera. Next, should I move forward? Now, what is latent heat of vaporization? Abdullah, have you noted this one?
Yes.
What is latent heat of vaporization? Vaporization means when you are converting 1 kilograms of liquid completely into gas at its boiling temperature. Boiling point. Like for example, 100 degrees Celsius is fixed. The temperature should not rise, indicating that the temperature will automatically will not rise when we are converting liquid into gas. For example, whatever the temperature is, it should be fixed. That is its boiling temperature. Okay, got it? समझ आया? So note it down, the amount of heat required to change 1 kilograms of liquid to its gaseous state at its melting, at its atmospheric pressure, at its boiling point. I'm write this. You done?
So can you scroll it up a bit? Can you scroll it up a bit? Yes, sir. Can you click a bit down?
Are you having a doubt?
No, sir. Like, can you scroll it a bit down? I didn't complete the last sentence.
Down. This one, what you want to write? Latent heat of fusion.
So before was latent heat, right? Just latent heat.
What is latent heat? Latent heat is simply the amount of, it is the hidden heat that is required to change the state of matter. Okay. And it is of
Yes,
two types, latent heat of fusion and latent heat of vaporization. Okay.
yes,
Got it?
yeah.
You noted this one, Abdullah? Naisha, are you there? Naisha,
Yes, sir.
not responding today. Yeah.
Yes, sir.
Now let me discuss this one further. What is boiling point and melting point? Let me explain it. Like, for example, I told you that when we are just boiling something, there is the liquid, the top layer of the liquid is open and it want to leave the surface, want to leave the surface. Okay? But it cannot leave. We require some heat to melt it, sorry, to vaporize it. Are you getting the point? For water, it is 100 degrees Celsius. For water, it is 100 degree Celsius. This temperature is 100 degrees Celsius. So the top layer want to move, want to leave the surface, but it is not leaving. It is requiring some temperature. Why it is not leaving? Which thing is that is prohibiting or restricting it to leave the surface? ऐसी क्या चीज है जिसकी वजह से वो लीव नहीं कर पा रहा? That is the vapor pressure. Sorry, atmospheric pressure. So this is the atmospheric pressure that is not allowing it to leave the surface. Atmospheric pressure. But when we keep on applying heat to it, the kinetic energy particle will leave, and when the kinetic energy particle will leave, then it will easily overcome that pressure. Okay. The problem is one thing, that what is boiling temperature, what is boiling point? Let me explain what is boiling point. Boiling point. Okay. So when a substance is kept open, it still exert a pressure, but that pressure is called vapor pressure. Vapor pressure. That pressure is called vapor pressure. Okay. Vapor pressure. We call it vapor pressure. That pressure is called vapor pressure. Okay. And this time when it is kept open and it is not evaporating, it means that the atmospheric pressure is much greater than the vapor pressure. Means particle want to leave, it is exerting a vapor pressure, but actually the atmospheric is much larger, so it is not allowing it. So we can say here the vapor pressure is less than atmospheric pressure. Atmospheric pressure. Atmospheric pressure. Okay. But when you keep on heating, so what would happen at 100 degrees Celsius? At 100 degrees Celsius or its boiling temperature, we'll say that the vapor pressure will become equal to the atmospheric pressure. Means the vapor pressure means the particles is applying pressure, and the this one, okay, the vapor pressure of liquid will become equal to the uh, uh, atmospheric pressure. What is boiling point? What is boiling point or boiling temperature? We simply say that the temperature at which vapor pressure of liquid become equal to atmospheric pressure. We call it vapor. The temperature at which the vapor pressure of liquid become equal to atmospheric pressure. Got it? Okay, समझ आया? For water, this temperature is 100 degrees Celsius. Pure water. Okay. So it is the correct definition for the boiling point. If you think that boiling temperature is simply when we are changing liquid to gas, so that is the temperature at which liquid changes into gas, right? It's okay. But this is a pro definition, that the temperature at which the vapor pressure of liquid become equal to the atmospheric pressure, that is called boiling temperature.
So we wrote the definition of boiling point and melting point before.
Melting point is the temperature at which you can simply say that वहां पर हम लोग वेपर प्रेशर नहीं लिखेंगे, क्योंकि सॉलिड्स को वेपर प्रेशर एग्जैक्ट नहीं करते. So we will say that the temperature at which this solid substance changes into the liquid substances. Okay. At one
No,
atmospheric. Yes, I will
sir,
say.
I'm saying that before we already wrote the boiling point and melting point definitions.
Before.
Yes,
I
sir.
think okay. Okay, sure. No problem. Okay. Done? The resolution of 90.1.8. Done. Should I move forward?
Yes, sir.
Now there is an conversion process. Conversion units. Conversion units. You know that the standard temperature is standard unit of the SI unit of Kelvin. Sorry, SI unit of temperature is Kelvin. Is Kelvin and denoted by K. Okay, it is denoted by K. SI unit of temperature is Kelvin and it is denoted by K. Okay, and you know that we also have Celsius scale. We also have Fahrenheit scale for the temperature also. So we can simply say that 0 degree Kelvin is equals to 273 degrees Celsius temperature. Sorry, minus 273 degrees Celsius. Or we can say that uh, 0 degrees Celsius is equals to 273 degree Kelvin. Okay. So if you want to convert any degree Celsius to Kelvin, any degree Celsius to Kelvin, simply add 273 to degree Celsius. 2 degrees Celsius. Let me explain you this one, what I'm saying, what I'm trying to say. Have you noted this one? First you note it down, then I will explain. Have you noted this?
Yes, sir.
So let me first convert this. Just try to convert this first. Um, Convert this one. This is the correct sequence. Question number 6. What is the correct answer for this?
A.
Yes, sir. A.
Yes.
298 plus 301 plus when you add 273 to you will get this one. And for this one, question number 8. अनीशा,
Yes, sir.
बेटा आप कहाँ थे?
Sir, I was here in the class.
मैं तो रेगुलर चेक कर रहा हूँ, आप नहीं थे।
Yes, sir. बीच में गई थी.
क्या?
Yeah, yeah.
क्या है? नोटेड? क्या आंसर होगा? इसमें 273 ऐड करो, इसमें 273 से देखो, हम लोग लास्ट डिजिट से चेक करके देखते हैं। पहले इसमें 3 ऐड करेंगे तो 8 होगा। 8 किस में? इसका मतलब बी और सी में से ऑप्शन है। फिर 273 का 3 हुआ ना लास्ट में पहले।
Sir, it's C. Sorry, C.
इसमें 35 में 5 ऐड करके देखो, फिर 3 में 3 लास्ट का नंबर है, फिर 6 ऐड करोगे तो 9 होगा। 8 और 9, 8 और 9, ये तो बी और सी रिजेक्ट हो सकती है। 8 एंड 8 में जब 3 ऐड करोगे तो 1 आएगा, 2 आएगा, ये 2 11, तो सी इज द करेक्ट ऑप्शन। समझ आया?
Yes, sir.
नेक्स्ट। जब हम लोग स्टेट चेंज करते हैं तो टेम्परेचर कांस्टेंट रहता है। तो अच्छे समझ आई, टेम्परेचर क्यों कांस्टेंट रहता है? बिकॉज हीट फ्लोज इन ओवरकमिंग द फोर्स ऑफ अट्रैक्शन। हीट फ्लोज इन ओवरकमिंग द फोर्स ऑफ अट्रैक्शन बिटवीन द पार्टिकल्स ऑफ लिक्विड्स। अगर लिक्विड सॉलिड में गैस में कन्वर्ट हो रहा है तो। और सेम गैसेस अगर सॉलिड अगर लिक्विड में कन्वर्ट हो रहा है तो तब भी ऐसा। नाउ व्हाट आई एम सेइंग हियर इज दैट ध्यान से समझना बेटा। What is favorable conditions? For example, if I'm having these particles and I want to convert it, because I want to make them closer, what is that suitable condition for that? One is pressure, another one is temperature. So let's suppose it is gas and you are converting it into liquids. This is liquid. So can you tell me that which is favorable condition for this one? Means should I increase the pressure or decrease the pressure? First of all, tell me. If you are converting gas to liquid, so what you will do with pressure? Should I increase pressure or decrease pressure?
Increase.
Hmm? Increase.
Yes, sir.
We should decrease. So sorry, yeah, it is. We should increase pressure. That is correct, Beta. Increase pressure means when you increase the pressure, let's suppose this is a gas in the piston, in a cylinder, and you have a piston over here. Okay, and the gas particles are filled here. So when you apply the pressure over it, then what will they? They will come closer. Simple. They will. They will come closer. And you apply the pressure. By applying high pressure, then they will come closer. The closeness of the particle will depends on the pressure. So if you apply the pressure, then they will come closer. Okay. Got it? Yes or no? And the
Yes.
second reason is that they are far apart just because they have more kinetic energy. So if you remove their kinetic energy, they will come closer. So increase in pressure and removing of kinetic energy means removing of heat. Because kinetic energy बढ़ानी है तो heat दो, kinetic energy कम करनी है तो heat निकालो. Release the heat, okay? And decrease in temperature is the favorable condition. Decrease in temperature. Okay, note it down, please. Conversion of liquid to solid. Sorry, gas to liquid is favorable when we increase pressure and decrease temperature. Yeah? Done. And if you want to reverse this process, what you will do? Let's suppose you have liquids and you want to convert it into gas. This is liquid and you want to convert it into gas particles. Then what you will do? You will increase temperature, opposite, and decrease pressure. Okay, got it?
Yes.
So
Yes, sir.
please, tell me what's the answer for this one. Tell me. Question number one, what should be the answer?
C, sir.
Well, saying C.
C, sir.
B.
B. But a solid compression of gas would not, which of the phenomena would rise on increasing temperature. So if you increase the temperature, the kinetic energy of the particle will increase. So if you are just compressing the gas, the temperature is not favorable. So the option which is carrying compression of gas, this is not, it is not favorable with increasing temperature. You should decrease the temperature if you want to compress the gas. Okay, if you want to bring its particle closer, compression means bringing the particle closer, so your kinetic energy should be decreased. That's why C is the correct option. On increasing temperature, evaporation increases, diffusion also increases, and moreover, expansion of gas also increases.
Okay, sir.
Not it. And what is this one? Question number two. What should be the answer to question number two?
D.
D. So when you are changing, what is saying that she went to the uh, natural gas compression unit, means where we are compressing the gas and we are converting into liquid, and found that the gas can be liquefied under the specific conditions. I told you liquefaction of gas. If you have gas particles and you can't want to convert it into liquid particles, so means you have to increase the increase pressure, because when you increase pressure, the particle will come closer, and lower temperature, isn't it? So you have to remove their heat so that they will come closer. Got it? So at high pressure and low temperature, C is the correct option. Got it?
Yes, sir.
Yes, sir.
The next topic will be, yes, this is the last question, question number 10. What should be the answer to question number 10? Distance between the hydrogen molecule kept in a cylinder will increase. How will you increase this is the correct option. Which of the following is correct? Condition when you want to increase the distance between the hydrogen molecules. You have a cylinder and it is carrying the hydrogen, okay, hydrogen gas particles. Hydrogen gas particles. So you want to increase the distance between them. How will you increase the distance? increasing pressure on hydrogen cylinder in a container. If you are increasing the pressure on then it will make it closer. Okay, got it? समझ आया?
Yes.
Yes, sir.
Some hydrogen leaking out of the container. हाँ, कुछ हाइड्रोजन अगर उसमें से चली जाएगी तो जाहिर सी बात है, वो चली गई तो खत्म हो गई, तो कंटेनर में है ही नहीं। अब क्या होगा? अभी भी ये पूरा कंटेनर को फिल करेगा। When the gas is leaking, I think the pressure कम हो जाएगा, ठीक है, और ये दूर दूर हो जाएगा। समझ आया?
Yes.
तो some
Yes,
hydrogen
sir.
leaking and if you increase, yes, अगर तुमने ये हाइड्रोजन गैस को ट्रांसफर कर दिया किसी बड़े कंटेनर में, ठीक है, तो फिर तो भी डिस्टेंस कंट्रीब्यूशन बढ़ जाएगा। तो इंक्रीजिंग द वॉल्यूम ऑफ द हाइड्रोजन कंटेनर, यस, तो हो सकता है एडिंग मोर हाइड्रोजन, इसमें और हाइड्रोजन डाल दोगे तो फिर तो और कम हो जाएगा। गॉट इट? तो सेकंड एंड थर्ड इज द करेक्ट ऑप्शन। गॉट इट?
Yes.
समझ आया? सागरिका समझ आया?